Hi all. Thank you all for coming here. Uh, let's give a warm welcome to Mr. Julian for his speech on Introduction to JSON Schema. Thank you.
Audio good? Okay. Hi. Thanks everybody for having me here again. I was here last year, really enjoyed the conference. So props to the organizers and to everyone who attends. This is me on the internet in whichever ways you might want to actually get in touch with me. GitHub, Twitter if you feel like it, and IRC, which is what I would prefer. I have to give a shout out. So I'm from New York. I work for a company called Magnetic. We do like marketing technology, bidding on online advertisements, that sort of stuff. If you're interested in talking about work things, that's my work email. We have offices in London, excuse me, and like everyone else, we're hiring, including in New York. Also related to work, we run and have run quite large PyPy deployment in production for the past 2.5 years, which those of you who've talked to me already know that I very much like talking about. So if you just want to talk about running PyPy at very large scale, you can come talk to me. So JSON schema. So here's an easy one. Raise your hand in the room if you've never heard of JSON, which is perfectly fine. No one. And so just to kind of speak that out a little bit. So JSON is a kind of structured object representation format with a bunch of different types. It's very popular. It's kind of human readable. It's sort of easily compressed, so you can also kind of shuttle it around a little bit. People use it for APIs. And so people create this kind of structured representation of their data, and sooner or later when you create structured representations of data, someone comes along eventually and says, I want to actually be able to schematize the data that I just represented so that I can inform people or validate against a particular schema that, that the data that I'm sending or the data I'm receiving is in a particular shape. And so along comes JSON schema, which is basically a specification for doing exactly that. So here's an example of a JSON document. And I'm sure everyone has seen things like this before. And JSON schema is a specification. Confusingly, the Python library is also called JSON schema, confusingly or not, I guess. You can find it there on GitHub, or you can just pip install the name of the library. Slightly harder question, I guess. Raise your hand if you've ever used the library already. One. OK, not bad. So let's get right into it. So some terminology first. So the documents or objects or data that we're trying to represent, we call the instance. So in this case, I have an instance. It's a number, or happens to be an integer. And there's a schema that I would like to use in order to validate instances. So that schema is kind of the, well, there's the trivial schema, which has nothing inside of it. But other than that, that's kind of the simplest useful schema. Which is just basically specifying what type the instances that I want to receive are going to be. So while JSON, JavaScript, while JavaScript basically doesn't have integer types, JSON schema does. So you can say type integer, and that will only validate against integers. So here's the kind of most general basic form of the API for the library. So you can just import this function called validate. You pass in an instance, you pass in a schema, you call this function, you hit enter in your REPL, let's say, nothing happens. Because the API for this function is basically, if your instance is valid, no one complains. Here's another instance, same schema. Clearly, this one is not valid. Same call, now you get a traceback. So if you pass in invalid instances, you get this perhaps long-winded traceback that basically says, first of all, what you passed in is not an integer. Failed validating the type validator in the following schema on the instance that you passed in. These kind of two things on the bottom here don't seem very useful when we're validating such a simple schema. But if you watch them a little bit, you'll find that as we start getting slightly more complicated things, they start to become useful so that you can follow what was happening. So just a brief general note. So what are the types of things that JSON schema is going to allow you to validate in your JSON documents? So you can validate types. We already saw that. there's 7 primitive types in JSON schema. It's whatever types you probably are thinking of: float, number, integer, string, object, array, and whatever else I'm forgetting. So you can validate that instances are of particular types. You can validate that those instances are of particular lengths. So you can say an array has to have at least this many elements, or at most this many elements. A string has to be at least this long, or at most this long. An integer has to be at least this amount, or at most this amount. You can validate the contents of containers. So you can say arrays, their elements have to validate against this particular schema. Objects, you can say their properties have to be of this particular schema. You can validate the form of particular instances, which is things like you can say, I want this integer to be divisible by 10 for whatever reason. Or I want this string to be of a particular shape. And then higher order operators, which we'll talk about later, which are kind of interesting. So back to our document before, we would like to schematize this particular document. So let's write a schema for it. There's going to be a bunch of lines on the next slide, but they're not that scary, I promise. So here's a schema for potentially documents of the type that we just showed, slightly less trivial than before. So first of all, it's an object. Properties is a validator. That means I'm going to specify the name of a bunch of properties. If they're there, then they need to have this schema. If they're not there, that's fine. Whoop. There goes the battery. Oh well. We'll do this by hand. So if they're there, they need to satisfy each of these schemas. If they're not, that's fine. So for example, the name property there needs to be a string. If it's there, the location is going to be an array like we saw before. Description doesn't really do anything. It's just there kind of for information for anyone reading the schema. So maybe we're letting them know that we're trying to represent latitude and longitude. And then items is a validator that basically says when items is an array, it means all of the corresponding elements have to match those schemas. So this one means first item in the array has to be type number, at least -90, at most 90, and then correspondingly the second one. So before I go too much further, I have to be slightly pedantic. So the name JSON schema is slightly a lie. Because if you were paying somewhat close attention, I didn't really pass in any JSON anywhere. So JSON's text, which really, I guess, should be represented as the Unicode type in Python. But we passed around Python objects like Python ints and Python like dicts and things like that. So really, JSON schema doesn't actually validate JSON at all. It validates the types of Python objects that you're likely to get from deserializing JSON. You can play a little bit with that also. But just to be clear, you're passing in just regular Python objects, which means actually you don't even need the source of those objects to be JSON. If they came from someplace else, you can still validate them with JSON schema. That's either a good or a bad idea, depending on where they actually came from. So let's talk about a slightly more interesting case. So here's an instance on the left. It's an array with the number 1 inside. And on the right is a schema for that instance, which the instance is particularly wrong for. So on the right, we're looking for implicitly arrays. Arrays whose items are of type Boolean, and that have at least 2 items in them. So we're looking for arrays of size at least 2, and whose elements are true or false. So clearly, this instance on the left has a bunch of problems. To do some more useful things with the schema that we just made, we're going to use the actual workhorse objects in the library. So there's a class in here called draft4validator, draft4 being the current version of the specification. A little bit boring. But we can create a validator that implements this version of the spec, which is what we've been using. And basically, what you need to do at the most basic level is just to pass in the schema. So now we have an object that can validate many instances against this particular schema that we've just passed in. And implicitly, when we called that validate function before, what it was doing was basically creating one of these for us, calling a method on it, and then throwing it away. So now we're kind of more free to kind of reuse this object. So I just passed in the schema that we have. And if I pass in some valid instances to the .validate method now, which is the functional equivalent of what we've been calling. Again, nothing happens, same API. If the instance is valid, execution just continues as normal. If we pass in our invalid instance, we get this traceback, similar to what we've seen before, although now I'll point out that this is slightly more interesting because now it's telling us, rather than giving us the entirety of the schema that we were validating, it's saying it was inside schema index items. So it was inside the index of items inside our schema, which is this subschema. And it was validating instance subscript 0, which is the element 1, not the entire instance. So if your instance or your schema starts getting quite nested, the tracebacks that you'll get will most likely kind of dive into your instance close enough that you'll be able to see a bit easier what was happening. So this is fine, this works. We got an error. It was an error that happens to tell us that 1 is not a Boolean, which is certainly true. But I would like to do better. So you can imagine, for example, we're rendering a form on a web page, and someone gave us some invalid data. If someone gives us invalid data with like 200 things wrong with it, it would be quite annoying from a UX perspective for us to actually, like, every time we tell the user, like, this thing's wrong, and then we send them back a response, and then there's 199 other things wrong with it, and so we do this nice little dance 199 more times. So it'd be nice for us to just know, like, I have an instance, tell me all of the problems with that particular instance. And for that, there's a method on that object called iter_errors, which basically gives you an iterable of errors. And if we pull off the message, which is that thing that you see on the first line of the traceback from each of those errors, you'll see 2 errors in here now. One that says that 1's not a Boolean, which was the error that we encountered when we called validate. And then the other error, which says array with 1 inside of it is too short, is also there. Feel free to shout out questions or raise your hand with questions as we go if you have any. Any questions so far? No, cool. I'll try to leave some time at the end too. So we saw the message attribute. Just as a brief overview, we'll see some of these later, but there are kind of 3 categories of things that you can pull off those errors. So there's kind of the developer-ish readable message. Then there's information about why that particular error happened, which we'll see in a bit. And then there's metadata about what was actually being validated, what was the instance, what was the schema, what's the path from the original schema into where we were validating, what's the path from the original instance into what we were validating, that kind of stuff. So just briefly, there's an object in there also called error tree, which is basically an object that takes a bunch of errors and then lets you walk the errors as if they were the instance. So just to make that a bit clear, if we make an error tree out of those same errors that we got before, then we can index the tree by index 0 and then inspect the errors at that spot. So that corresponds to the subscript 0 in our instance. And so the error at that subscript was that that element at that index is not a Boolean. So if you look in errors, you'll see the type validator errored there, and the error was that it's not a Boolean. Make sense to everyone? Cool. Let's talk about references. So we're all good programmers. Like many good programmers, as soon as you give us a tool, we start to want to actually give names to things. So that's what references are. So here's a schema. There's 3 properties in here trying to validate an object with a name, a nickname, and a username. All 3 of those are strings, and all 3 of those are non-empty strings because who has an empty name? So this is a bit repetitive. So we define refs. So refs are, they use this $ref to tell you that they're a little bit special. And the thing on the right is basically arbitrary URIs. In brief, in this case, what we have on the right is called a JSON pointer, which basically means the hash symbol means the document itself. It's the self-reference. And then slash definitions, you basically just resolve it as if it was a path. So slash definitions is here. Slash namelike is here. So this schema is functionally equivalent to what we had before, except that now all 3 of these, except my typo, are basically references to this one unified schema at the bottom, which, again, if you're a programmer and you're thinking that these things should evolve kind of together, then when someone comes along and is like, you know what, like Jimmy keeps sending us names that are like the entirety of Shakespeare, and so we should probably limit the length of our input too, maybe to 4K, let's say, you can just add that to the bottom schema, and now all of a sudden it applies to all three. Make sense? Questions about that? Good. So another example. So how about non-empty sequences? So someone says, I want to write a schema. It should validate against every non-empty sequence where the definition of sequence is the same definition, let's say, as if we were using Python types. So strings and arrays, or strings and lists in Python. So because of the way that schemas work, validators that don't apply to the type that you have actually just are ignored. So min items only applies to array, and min length only applies to strings. So you can just put them next to each other. And then as long as those types make it through the type validator, this one will only work when it's an array, and this one will only work when it's a string. Slightly confusing, I think, unless it's pointed out, but that's the way it works. So this schema actually validates against non-empty sequences. You pass in an empty string, you'll get an error. An empty array, you get an error. String with some length or an array with some length, this will work fine. But now a slightly more complicated example. So someone says they want to validate instances that are either monikers, names, or aliases. So what does that mean? They give you examples. So our instances are either going to be things that look like that, the letter S, capital letter S, or it's an object with at least one property in there called name, or an object with at least one property in there called alias. Any of those three instances someone would like to be valid. Our product manager, lovely product manager. So I'm using some references here only to make this fit on two separate slides. So the new thing here is this one-of validator, which is an example of the higher order validators we were talking about before. Higher order validators are basically just ways of combining other validators. So the one-of validator does exactly what it says. An instance is valid under one-of if it validates against exactly one of any of the schemas in the array there. So I just literally basically translated what I just said into a schema. So one of either a moniker, a name, or an alias. And now we can go off and actually define the schemas for those three things. So here they are, not very exciting. You've seen these before. So a moniker is a string. Pattern is a regex validator. So you can pass in a regular expression pattern. So here's one for A to Z, at least one capital letter. Name is an object. Required is the validator that actually means when I give you a property, it must be there. So this one says it has to have name. And then same thing for alias. So here's what happens when I pass in the empty string. Sorry, I know it's a bit hard to see. But I passed in the empty string, which isn't valid under any of those three things. And that's exactly what the traceback tells you. It says, not valid under any of the given schemas. It was validating the one-of, which is this schema, the entirety of this schema. And that was the instance. So all of this is true. Your empty string isn't valid against any of those three schemas. So nothing's lying to you. But it would be nice if we were able to actually get a bit more. So if you look at the iter errors, which is going to give you all the errors, there's just one in there. Reason being that every validator produces at most one error. So we had one validator, it's the one-of validator. It can either error or not. Basically, an instance can either be valid under it or not valid under it. And this one is not. So one-of produced an error. It said empty string is not valid under a particular schema. But what we would like potentially more out of this is if I have a one-of with 10 things inside of it, which I wouldn't necessarily recommend, but if I did, it would be nice to know why, for each of those branches, why wasn't my instance valid under any of those particular schemas. So for that, there's the context attribute of errors, specifically this one. So if you look at that error and you look at its .context, what you'll see is basically one error for each branch in the one-of. So if you remember, our one-of had 3 branches inside of it. One was non-empty capital strings, and the other 2 were objects with property name, object with property alias. So there are 3 errors in there, each one telling you why that branch didn't work. So the first one didn't work because empty string doesn't match that regular expression. The other 2 didn't work because it's not an object at all. So it's a bit more useful for knowing kind of all of the things that went wrong if you have branching or some higher order validator. But maybe for debugging purposes or otherwise, that's still not good enough. For that, there's multiple functions, but at least one called best match, which is basically a heuristic for you give me a bunch of errors, and I tell you which one is most likely to be the one you care about. So still passing in that iter errors on the empty string. When I pass that into best match, it heuristically decides that the one that you probably care about is the one that says that empty string is not A to Z plus. So you just get that one error instead of the 3 errors. And if, for example, you had an instance that had 10 things wrong with it, and then one of them was a one of, and that one of had kind of a nested, like, nasty thing, best match is going to traverse all of that and decide which one is most likely to be the thing you want to fix first. There's other things in there, but this one is typically the most useful one. Questions? Good. So let's talk about format. So format is a validator that basically lets you define the form of particular primitive types. So for example, a string. I have a string, and I want people, first of all, to know that it should be a date. So I can say type string format date, and that means the strings that you give me are supposed to be dates. Now, they're not actually used by default for validation. That's what the specification happens to say. But if you do want to actually formally validate that instances that you're provided actually satisfy the formats in your schema, you can pass in this object called the format checker, whose job it is to basically validate formats. So same kind of creating a validator object off of that class, but we pass in this new object called the format checker. And now, again, sorry, it's probably a bit hard to see, but I passed in the string 2014-01, which isn't a complete date. And so now the format checker and the validator therefore complain and say, failed validating format on this instance, it's not a date. So of course, if you added a day to that, this would validate. And you can actually add your own. So if there's a bunch of formats that are predefined, some of them are easy to use and readily available, and some of them aren't. Like you can validate whether something is a valid CSS color. I don't know why people want to do that so much, but you can. You can actually add your own, though, if one doesn't exist. If for whatever reason you want to actually specify a schema that says that instances should be prime numbers. So assuming that you have already some prime checker, all you do is basically decorate a function, say that it checks this format called prime, do whatever you have to do to actually decide whether the thing is prime or not, and then now you have you have the ability to basically write type string or type number format prime, and instances will validate only when this function says that they're prime. Also makes sense? So, meta schemas. Everyone gets very excited about metaprogramming. So, in case you haven't noticed already, one of the nice things about JSON schema is the specification, is that JSON schemas are just JSON, right? So given that they're just JSON and that JSON schema is a format for validating JSON, there are schemas that specify what a valid schema are. So those are called the meta schemas. I'm not going to show the entirety of the meta schema on the board for draft 4, but it's not very long. It's about 50 lines of well-indented JSON. But there is a class method on the object that we've been using that can basically take a schema and tell you whether it's valid under the meta schema. So you call this .checkSchema class method, pass in a schema, which in this case happens to be invalid. It's like type, but the value of the type validator there is an object, which isn't allowed. When you call this class method, you will get a traceback. It's very similar to the traceback that we've seen before. It says schema error now instead of validation error. But otherwise, it's exactly the same. Excuse me. So it's saying that object is not valid under any of the given schemas. So you can tell that there's a higher order validator in here somewhere. So if we just read this, so it says failed validating any of, which is like one of, except you can validate against more than one. So failed validating any of in schema properties type. So this is the meta schema, and it's saying in the meta schema there's a properties, and specifically there's a subschema that defines what the type property is allowed to have. And it's saying that the meta schema says that what you provide for the type validator is any of the following things. So there's just two things in there. It's either any of the simple types which I mentioned before. So you can say type string, type number, type object, whatever. Or you can provide an array with at least one object inside, with at least one string in there whose items are one of those simple types. So you can provide arrays of simple types, and they have to be unique. It's a little weird. So if you're not one of these two things, that's why your type's invalid. So this is the meta schema saying your schema is not valid because you didn't provide either type string or type array of string and number. Make sense? And again, the meta schema is in no way special. So in fact, there's a class attribute called meta schema. You can create a validator if you'd like, whose schema that it's going to validate against is the meta schema. And that gives you access to all of the same functions that we talked about before. So you can call iter errors if you have a schema, which in this case is an instance. If you have a schema that's wrong in multiple ways, you can see all of the errors that are wrong with that particular schema. So this one, for example, still has that problem where type is an object, but now also we're providing like a string to minimum. So that doesn't make sense either. So in this case, there's two errors. One is wage is not a number, and the other one is that thing is the same error as we saw before. So we have another 10 minutes-ish if I leave 5 minutes for questions, but maybe I'll pause now just in case there are any general questions because, well, actually, let's go here first. So here's a list of things that are possibly useful to see. The slides will be online. I'm sure they are already online, but I'll send them out again. So the top one is how you get the library. Just pip install if you'd like. The second one is kind of a friendly introduction to the specification. It does give examples in various languages, but it's basically a kind of tutorial for basics of writing JSON schemas. So if you just want to go through that again, or there are some stuff in there that I haven't actually covered, that second link will give you a tutorial. Third one is the documentation for the library. So check that out if you'd like. There's plenty of stuff in there that I haven't talked about either. The fourth one is the website for the actual specification. So you'll find there implementations of validators in every language you've probably heard of. And also you'll find the actual specifications there, which are out of date and being refreshed, but they're there. They're very technical, so if you're actually looking to learn about the spec, the second link is what you want. But if you want to actually read a very IETF sounding document, you can go read the specs in the official webpage. The fifth link there is of less interest to people who want to use JSON schema to validate things, but that's a cross-language, cross-platform test suite, most of which I wrote, which basically allows you to write validators in any language you'd like. And then the test suite will basically give you a bunch of valid and invalid cases and that are theoretically comprehensive, although if you find cases where the test suite is lacking, please let me know. But it'll basically give you a suite of examples for each of the validators, for each of the drafts. And if you validate under all of those, your validator probably works, at least in some sense. And then the bottom thing is actually kind of neat. Let's see. If I have internet access, I can probably pull it up. Assuming I can type. So I'm going to type on a Swedish keyboard, which will probably not go well for me. So this is kind of a fiddle. So you've probably seen this for things like JavaScript, HTML, CSS kind of things. So it's a fiddle where you can you can provide some JSON. You can provide a schema. You can resolve some references. You can click around. It will actually generate what it thinks is a schema for what you're trying to go for. And then you can validate stuff against it. It's kind of nice to play around a little bit in here. Excuse me. I don't know which actual implementation of the validator this is using on the back end, but I would assume it's the JavaScript validator, which is also fairly good. Edit view has been disabled while bugs are fixed. Okay, that's good. Yeah. So any of those, they're in the slides, so you'll have access to that. Yeah, any questions about anything at all? Yes, sir. Can you just say your name? Matthias.
If I may ask two things. Is it possible to have any custom validation messages? And also, is it possible to generate schemas from any ORM, possibly?
Yes, two common questions. So the first one, the answer is yes, no, or yes. So no, there's no very straightforward way of basically saying when this thing fails, this is the message that should happen. In a very broad sense, the messages that you see when you get tracebacks and the fact that you get tracebacks are basically directed at developers, not at end users. So the kind of target for those things is like the person who wrote whatever thing is supposed to be kind of able to handle that and read it and understand what it means. But this question comes up very often. So I'm not against adding such a mechanism. It wouldn't be portable because there's no such thing in the specification, which is why I've been hesitant so far. But the answer is yes, because all of those properties that you saw before, all of those attributes that you saw before allow you to basically do it on your own. So for example, there's an attribute on the error that basically tells you which part of your instance was invalid. So you're free to write basically try, validate, accept validation error. Let me see which property failed, and then look up in a dictionary which error message corresponds to that particular property. Like, it's about 10 lines of actual code, probably even less. So you just provide a dictionary of like paths into your instance as a, let's say, tuple of strings or a tuple of indexes, and then the value would be the error message that you would like. And then when you call validate, if you get a validation error, just look up which the appropriate error message is and return that one to the user. So no, there's nothing in the library for doing that. I would like to see someone try things the way that actually does work now and then come back to me and tell me that it's inadequate and why it's inadequate. And then if it is, then we should probably hash out how to make it work. But I suspect that you'll get very far by just doing things that way successfully. And what was your other question? Sorry.
If it was possible to generate schema
Ah. So again, another common question. So obviously in the general case, it's not very possible. So in a general case, it's not even sensical really to do that, right? Like you saw that website tries to do it, right? Like you give me some data and it tries to guess what schema you want, but you can't really go in that direction. Like you have to give me an exhaustive list of all of the instances that you actually want to be valid and an exhaustive list of all the instances you want to be invalid for me to be able to infer. And even then, it's kind of hard. If you instead mean basically, so maybe what you mean that does exist is there are libraries built on top of JSON Schema, the Python library, which basically allow you to, you give me a schema, it creates out of that a class, and then instances of that class have to be valid under the schema, and then if you're into mutation and you actually mutate that class, or instances of that class, they will make sure that mutations to that object still become valid under the particular schema. I'm not so into mutation, so I don't use those libraries, but they do exist, which are somewhat the equivalent of an ORM, I guess, if your theoretical database is just objects in memory. Is that what you meant? Close, maybe? No, sort of? So there are some things. Maybe we can talk a little bit more. And there are a bunch of tools basically built on top of JSON Schema, which may or may not do what you're looking for. Other questions?
How would JSON schema be different from XML and document type definitions and all those stuff that existed 10 years ago and then everyone stopped using?
Yeah.
Everyone except in the enterprise.
Yeah, another good and common question. To some extent, the answer is, what's wrong with XML? Why did anyone invent JSON? So when you answer that question for why XML is bad and someone invented JSON, then the next step after that is like, someone thought XML is bad and invented JSON, but then someone was like, yeah, but XML has a bunch of good stuff. Why don't we have that over here? And someone was like, okay, let's just do it over here. And they just kind of started building up an ecosystem on this side. So you have XML path, you have JSON path. You have like XML pointer, you have JSON pointer. You have like XML, like XSLT, I think probably exists for JSON. I've never seen it. Like at the top level, someone disagreed and was like, we don't like XML. It has too many brackets in it. So we're going to invent JSON, and braces are way better. And so like you had this, and someone said, no, I don't like that. I'm going to do this thing. And then once that happened, then you kind of schism at the top. Everything else just kind of is like, yeah, we want to create parallel versions on this side because we like JSON better. So to some extent, there's no real answer to your question other than if you prefer JSON over XML, these tools are there to basically allow you to still have some of the things you like about XML and its ecosystem. Make sense?
Yeah.
Anyone else? Sir.
Hi.
Hey.
Thanks for the talk. I have a question slightly related to the previous one, but not as terrible as XML. Have you heard about JSON LD? And I know it's kind of conflicting thing, but what do you generally think about using a standard that would allow to understand that, for example, latitude and longitude are coordinates of some place? I know that I didn't explain properly, but maybe you will. The differences.
I won't, because I've seen the letters, but very little else. I know it's a competing spec, but not much more. So I mean, does anyone, if anyone else has another question or is thinking about it, then we can move on. Otherwise, yeah, maybe you want to like tell me 30 seconds about what it is.
Yeah, so it's a standard from W3C,
Okay.
the same as HTML. And the standard is about putting semantic web into JSON readable format. So you can define a context which is similar to the schema. You can leave the same format of JSON that you're using, but instead you can say that the name is actually schema.org name of a person, and coordinates is actually the location of a place. And then you can consume different JSON files from different endpoints, and you still know that the data you're getting is of this format. You can still make same set of different locations.
Yeah. Sounds good. I probably would want to have a look at it. I will say two potentially related things. So one is that I actually only talked about half of the JSON schema specification. So there's also another half called the hyper schema, which basically takes JSON and turns it into hypertext. So you can say things like, I have a resource, it's JSON, here's its schema, and here are the links to other JSON documents, which sounds like possibly they're doing that too, maybe. So that's a complete other half of the specification that has nothing to do with validation, has to do with hypertext. And the other thing, I think I forgot. Yeah, I think I did. Oh well, I'm sure it wasn't important. Yeah, I'll have to look.
Perfect. Thanks.
Yeah. Anyone else? Last one, I think. No? Okay. Yeah, one last one.
When do you actually use JSON schema?
I was hoping to get out without answering that question. Yeah, there's a simple answer to that question, so I don't. Yeah, I don't actually use JSON schema. So I wrote this library probably about 3 years ago now, 2-3 years ago. And for better or worse, for better obviously, it got picked up by some large deployments. Great. I'm glad people found it useful. Like some people at MediaWiki I know use it, and like it gets like hundreds of thousands of downloads a day, which I'm pretty sure is like MediaWiki running like giant build farms or whatever. So people are using it. Me personally, I don't really use it anymore. I don't have. So I work for an ad tech company. We do deal with incoming JSON data, but we don't want to validate 400,000 or 500,000 requests per second coming in. If they're invalid, we'd just let them blow up and send someone an email later and saying, stop sending us invalid data. So I don't actually use it either at work or personally. Although if I did use it personally, there's things that are built on top of JSON schema, the specification, like RAML, if anyone's heard of RAML. So RAML is basically a way of combining a schema with like an API endpoint definition. So you say like this endpoint returns objects of the schema, and then you can actually generate clients and servers from it and all of those things, kind of like Swagger, if you know about Swagger. So now you'll ask me why someone invented RAML when there's Swagger. Don't know. Someone likes JSON. So that stuff I think I would be more likely to use because you can actually use it to do work for you, like generating clients and servers. But I don't use the actual library very often myself, except when I'm responding to bug tickets. Cool. Thanks, everybody.